Hi everyone, welcome to this first module in our first workshop on analysing Anopheles genomic data. In this module, we are going to begin by looking at one of the computing tools that we're going to be using to analyse data. And we're going to be looking at a tool called Google Colaboratory, or Colab for short. And hopefully what we're going to do in this module is explain what Colab is. And in Colab you create notebooks, and so we're going to explain what a notebook is. I'm going to show how to access Colab and use it to create and run notebooks. And then we're going to edit notebooks, and we're going to do some coding, which is going to be how we access and analyze data. So we're going to create code cells and text cells. I'm going to introduce you to a few basics of coding in Python. We're going to import and install some packages which we need, and in the end I'm going to show you how to share your notebooks with your colleagues via Google Drive. So that's what we're going to cover in this module. And just to explain then what Colab is. So Colab is it's a cloud computing service. So it's a computing service that Google run, and Google provide that service to us for free. And it's a great service for interactive data analysis. So you can use it to access and explore and analyze data, and then generate outputs like plots and tables. And it's also a very useful tool because you can access it through your web browser. So you don't need to install any software on your own computer. And because it's in the cloud as well, you don't need to download any data. You can just go to Colab and start analyzing data. So that's what we're going to do. So let's start by going to a web browser and going to Colab. So Colab is at colab.research.google.com. And what I'm going to do first is create a new notebook. So here I have a notebook, and this is the Colab interface. So this is the Colab user interface. This is where we're going to do our data analysis. And what we have here is a notebook, and a notebook is a kind of document which you can use to analyze data interactively. And here interactively means one step at a time. So you can build up your notebook out of a series of steps or cells. And in each of those cells, you may write some code that does some kind of analysis or access of data, and then see what it does, run it and see what it does. So you can write and execute code in a notebook. And you can also create plots, you can create tables, you can write text. So you can visualize, analyze, and record the outputs of your data analysis too. So a notebook is a great way of working with data. And your notebook, each notebook that you create through Colab is actually stored in your Google Drive. So when you're working in a notebook, everything that you do is saved automatically into your Google Drive. And this is the name of the file as it will appear in your Google Drive. So let's change that to start with to something that's perhaps a little bit more memorable. And let's begin building our notebook. So let's begin by creating some code cells. So this is a code cell. This is the first cell of my notebook, and in it I can write Python code. So that's code written using the Python programming language. So for example, I can write some code which calls the built-in print function and prints the string hello world. And you can run code cells, you can execute code cells. There's a couple of different ways that you can do that, but one way you can do it is to press the little play button here to the left of the cell. So if I click that button now, then Colab will run my code for me. And in this case, the code that we wrote, it has some output. So the output of running this code is here, is shown here. So if some code generates some output, then the output will appear immediately below. So here is a code cell now, which we've run, we've executed. Here is the input, the code, and then here is the output, which was generated. So we want to do more. We want to add more cells to this notebook. And there's a couple of different ways that you can do that. But if we want to add a new code cell, one way we can do it is to press this button up here, plus code. So now I have a new code cell in my notebook. And so let's try writing something slightly different piece of code. So here, let's write some code where I declare a variable and assign it a value. So here, foo is a variable and 42 is the value. So a variable is just a name which you associate with some value. And if I run this code cell, you can see this code cell does not generate any output. It runs some code, it does something, but it doesn't generate any output. So sometimes code cells generate output, sometimes they don't. And just to illustrate a couple of other useful features about working with code cells and working with code in notebooks. So sometimes you may have a variable like this variable foo, which I've declared here, but you maybe don't know what the value of it is, or you don't know what type of value has been associated with it. So if you ever want to inspect a variable, figure out what value is associated with it, one way you can do that is you can just type the name of the variable and run the code cell. And if a code cell just ends with a variable and you run it, then the value of that variable will just get printed immediately below. So here we see that the value of foo is the number 42. And so we can do other things. For example, we can change the value of this variable and then just output the variable again. If we to run this code cell, I'm going to do something slightly different, which is instead of pressing the play button here, I'm going to use a keyboard shortcut, and I'm going to use the shortcut shift. I'm going to hold down the shift key and I'm going to press the enter or return key. And that's a convenient shortcut because it runs this code cell and it also adds at the same time a new code cell below. So that's, when you're building up a notebook, that's very convenient. And so in this case here, we modified the name, we modified the value of this variable with a little bit of math. We added 1, and then we output the value of this variable here by just typing the name of it. And so now foo, the value of foo is 43. And this is also an example of how code cells can contain many lines of code. So you don't just have to write one line of code, you can write as many lines of code as you like in a code cell and run it, and all of those lines of code will get run together. Okay, so hopefully that's a useful introduction to code cells. We're going to come back a bit more to some other basics of coding in Python in a minute, but before we do that, I just want to introduce you to text cells, because it can be very useful to add text, written text to your notebook. You might want to keep notes, you might want to explain what you're doing, add some documentation around the code. So to do that, you can add text cells, and text cells you can add with this button here, plus text. And so here is a text cell, and I can just start writing text here, for example. I've written some text there, and the text that you write here is written using a special syntax called Markdown, and the only reason that it uses Markdown is it provides a way of formatting your text. So, for example, you can write some text in bold. And an easy way of making your text bold is to just select the text you want, and here's this button here will format your text as bold. And so here is your bold text, and on this half of the code cell, you can see what that's going to look like. So this is a preview of what your text is going to look like. And so there's other things you can do to format your text. For example, you could create some italic text. You can add hyperlinks. And there's other things you can do too, which I won't go into, but I'll provide some more information in the lecture notes. You can insert images, you can write lists, you can do other useful things to create some rich text in your notebook. When you're finished creating your text cell, you can exit that code cell just by clicking out of it, or by pressing Shift-Enter, and that will then just render your text cell. So here it just appears rendered for me. And one of the useful thing that you can do with text cells is you can create section and subsections in your document with headings. So let's add one more text cell, and let's add a section, and let's make this the title of our notebook. So now I've got a section heading, but this is not really in the right place because I want this to be at the top of my notebook. So what I can do is I can also move cells around inside a notebook. And these arrow keys here are useful for moving your cells around. So let's move this cell now up to the very top of the notebook. And so here we go. That can now be the title of my notebook. And you can also create subsections. So with subsections, you need to use 2 hash characters. But let's say now this is a subsection on code cells. And then down here, let's add another subsection on text cells. And so you can build up some structure in your notebook using headings and subheadings. And that can be very useful if you've got a long notebook, you need to break it up. And those sections and subsections are also visible now in your table of contents. So you can quickly navigate to different parts of your notebook if you need to via the table of contents. All right. So one other piece of useful information about working with notebooks and cells is that you can also, as well as moving cells around, you can delete them. So for example, if I've got an extra cell at the bottom here and I don't want that anymore, I can just delete that cell by clicking on the little dustbin icon. So that cell is gone now. So you can add cells, move cells, remove cells, and execute or run cells. Okay, so now let us do a bit more coding. So I'm going to just introduce a few basics of coding in Python. And so we don't to do this course, we don't expect or at all that you're an expert in coding in Python, um, but I'm just going to introduce a few just basic sort of fundamental building blocks of coding, just to give you a bit of familiarity with some of the kinds of things you can do. For example, you can do some math. So here, for example, let's assign a variable x, and then let's assign a variable y using a bit of arithmetic. So 3 plus 4 times x plus 1. There's a bit of arithmetic there. And then let's just inspect the value of the variable y. So if I run that code, we can see that the variable y now has the value 42. You can also write for loops. So this allows you to iterate over a sequence of numbers or a sequence of other values. So a for loop is written like this: for I in, let's iterate over a sequence of 5 numbers. So range 5 gives us 5 numbers. And then let's just print the value of I, which is our loop variable. So this for loop here just prints the first 5 integers. Another very useful thing that we'll see quite a lot in this course is that you can define functions. And a function is just a piece of code that you want to run perhaps several different times with different inputs or parameters. So let's define a function. Let's call that function greet. Let's give it a parameter name. And then don't worry about the details of this code here, but let's just print a string which greets the person, greets a particular person. So this code here defines a function. If we run this code, nothing actually happens, but we have now declared that function. And once we've declared a function, we can call the function. So to call the function, type the name of the function, and then we give it some particular input parameters. So here I'm going to give it the string Mario Caluzzi, and if I now run that cell calls the greet function, which causes the function code to be run with the given input parameter. And you can change that. For example, you can put in different input parameters and run the same function again with different input parameters. There's lots more you can do with Python, but there's just a few very sort of useful and common features. Another thing which I'd like to introduce is the concept of packages. So let's just look a bit at Python packages. And a package is a library of functions that someone else has written, and that those functions will do useful things. And so rather than you having to write all your code from scratch, you can use functions that other people have already written, and that saves you time. And there's lots of packages which are available for you to use, which have been written by other people. Some of those packages will be already installed in Colab. For example, there's a package called NumPy. NumPy is a package which provides lots of numerical computing functions. So if you're doing anything numerical in Python, NumPy is a very useful package. And you can access all of those functions by importing the NumPy package. And to import a package, you just type in a code cell, import, and then the name of the package. Now there's a little detail here, which is that some packages we use so often that by convention we just abbreviate the name of the package just to save some typing. So by convention we tend to abbreviate NumPy as NP. So if you want to abbreviate a package name, you can write import the name of the package as the abbreviation. And if you run that code cell, that imports the package, which means all of the functions in that package are now available for you to use. For example, we can now call the NumPy randint function, which generates some random numbers for us. So now we can generate, for example, some random numbers between 0 and 100, and let's generate 10 of those. If I run that code cell, NumPy has now generated for us 10 random integers, random whole numbers. Now some packages are already installed in Colab, some are not, but you can install them. And if you want to install a package, you can do that. And I'm going to show you how to do that. And there's a particular package which I'm going to illustrate with, which is a package called MalariaGenData. This is a package which we're going to use throughout the course to help with accessing genomic data. And so to install that package, we need to run a special code cell. The special code cell begins with an exclamation mark. And we use a tool called pip. Pip is a Python package installer. And so we write exclamation mark pip install -q just to make the output a bit less verbose, but then the name of the package. So MalariaGen_data, that's the name of the package we want to install. So this is a special code cell because actually this is not Python. This command, this pip command, is actually going to be run by the underlying operating system. So an operating system is just like your computer has an operating system, which may be Windows or Mac OS or Linux. In this case, the pip command is going through to the underlying operating system on Colab and installing the package for us. So this will install the MalariaGenData package. And once we've done that, we can import MalariaGenData. So now if I run that cell, now the MalariaGenData package is available to us. And we can start using it. We're going to look at this in a bit more detail, so don't worry too much about this for the minute. But to get access to Anopheles Gambi data, we would set that up with code that looks a bit like this. And we can start using some functions in that package. For example, I'm going to call a function called sample metadata, and I'm just going to run that. And now that's going to take a few seconds to run. While that runs, I'm going to introduce the next section that I want to introduce to you, which is inspecting data and visualizing data, viewing data. So there's some data which you want to view and you want to get a richer display of, and the first example of that is data which is in a table. So sometimes you're working with tables of data. That's what you might understand by a table. It's got rows, it's got columns, and in Python we call those data frames. So let's look a bit at data frames. So I ran this function here, sample metadata, and I assigned the result to this variable here, df_samples. Let's now inspect that variable by just typing the name of it and running that code cell. So df samples, the value of this variable is a data frame. And when I just type the name of that, I get a view of that data frame. And so what I'm seeing here are the rows. Here are the rows of that data frame, and then here are the columns of that data frame. In this case, each row represents a mosquito sample that was collected and sequenced. And the columns are things like sample ID, a country of collection, year of collection, and other columns too. And what you see when you view a data frame like this is you see, well, a summary down here. Here there's 3,081 rows in total, and there are 26 columns in this data frame. And because it's quite big, Colab is only showing me the first 5 and the last 5 rows. And so the other rows in between are just cut out, because otherwise it would be just too long. It would fill up your notebook. But it's really just to show that with data frames, then you do get this display of the table data. Another thing that you can do with notebooks is you can make plots. So let's just look at plotting very briefly. And we're going to be doing lots more of this through the course, but I just want to illustrate how you can make a plot, and then the plot itself will be output into the notebook. So let's just first of all give ourselves some random numbers to practice plotting with. So let's give ourselves a few random numbers drawn from the binomial distribution, just for fun. And there's several different plotting packages which you can use in Python, and we're going to use them all. But the one I'm just going to begin by illustrating is a package called Plotly Express. So I'm going to import Plotly Express. And this is another package that we tend to abbreviate just because we type it a lot. So here's Plotly. I'm importing plotly.express as px. And so, for example, I can use Plotly Express's histogram function to plot the data that we generated. So we're going to plot the data x, but because we are good data scientists, we're going to give our plot a title. And we might also just want to control the size of the output plot. So let's just give it some width and height parameters. And then finally, let's call fig.show. If we run this code now, we see that plot, that histogram, and that is shown here directly below. So this is just to illustrate that you can make plots, and those plots will appear in the notebook alongside the code. Okay. So 2 final things I'd like to show are, firstly, getting help. Sometimes you want to know more about a function, how to use a function, and there's a couple of different ways that you can do that. So let's look at getting help. So if there is a particular, like above, we just used a function from NumPy which generated some random numbers. It's the binomial function. But if you want to know more about that, if you want to get some help about that function, you can type the name of a function, put a question mark at the end, and then if you run that code cell, what Colab will do for you is it will print the documentation, the doc string for that function over here. So here is the doc string for that function. It shows us that there are 3 parameters, n, p, and size. Here's an explanation of what the function does. Draw samples from a binomial distribution. Here's an explanation of what the parameters should be. Here's what m, p, and size should be. And this is what the function returns. And then some more notes about the function. So that could be a very useful way of just trying to figure out a bit more how to use functions. Also, you can use the web. There's lots of good documentation online. So if I just Google NumPy random binomial, I will find the same documentation from the NumPy website. So here's the same documentation on the NumPy random binomial function. So there's two different ways of getting access to help documentation about functions. And the last thing I would like to show you is how to share your notebook. So one of the great things about notebooks is that once you've created them, you can share them with other people, and that can be a great way of sharing results, sharing your findings with other people, together with the code that you use to generate them. And as I mentioned before, if you're using Colab, your notebooks will be stored in your Google Drive. And you can share them just like you would share any other Google document. So just like a Google Doc or a Google spreadsheet or a Google Slides presentation, you can share your Colab notebooks. And so if you want to share a notebook, you can use this share button at the top right. And a very convenient way of sharing a notebook is to just create a link. So that's a web link. So I'm going to look here at this get link part, and I'm going to change to anyone with the link because there's nothing sensitive in this notebook. So I'm going to just get a link which I can share with anyone. And I'm also going to allow people to comment on this notebook. So I'm going to say, here's the link now to this notebook, and anyone that I send this link to will be able to view and comment on my notebook. So if I now copy this link, I can paste that link into an email or into Slack channel, or however I'm communicating with my colleagues, I can share that link. And if you're watching this as part of one of our workshops, what you'll be doing as part of the practical exercises is sharing the link to the notebook that you create in Slack. All right, so that is everything I was going to cover in this module. It only remains for me to say that it's time to do the practical exercises. All of the information about the practical exercises for this module are available on the course website. So the course website is Anopheles Genomic Surveillance.github.io, and we're going to go to module 1. Here on the website is everything that I just ran through is here in the module 1 lecture notes. Right at the bottom are the practical exercises. So here are the practical exercises which I'd like you to try. But basically what I'd like you to do is go to Colab and try out everything which I've just demonstrated. So go to colab.research.google.com, create a new notebook, add code cells, add text cells, practice deleting, moving cells around, practice writing some code, practice working with data frames, try making some plots. And then when you've had enough of all of that, make a link to your notebook and share it with someone. In particular, share it via the workshop Slack channel so that we can all see what we've created. Okay, great. Well, hopefully that's a useful introduction to Colab and to notebooks. And that's it. Thanks.